Hey guys, how's it going? So today we're going to do probability, and we're going to this is going to be an interesting topic in that we're going to cover it by just doing. Okay, so we're going to have a series of questions. We're just going to do all those questions, and then I'll be telling you some very useful tips. So for example, sometimes they actually use specific words that you can actually tell if the events that you're dealing with are mutually exclusive or they are independent, and also what those mutually exclusive and independent, what they actually mean. Okay, so this will be a very useful topic for you, and it's one of the easiest because it's kind of routine. You just have to know a specific games, and you have to know specific characteristics for some things like coins, die, and all that. And then most people, they actually do know, just because this is where some of the games that we used to play as kids. So you probably have a very good start point at actually understanding them. So for example, a deck of cards, used to play deck of cards obviously with your friends. Maybe you probably do even now. Some of those aspects, they're really so easy sometimes. They're really so intuitive that it's easy to score on them. Okay, so what we're going to do here is I'm going to define for you what probability actually means, and then we're going to just catch up everything else just by doing these questions. So probability, it's a measure of, at least the way that we're seeing it in maths. We deal with something called theoretical probability. Okay, so theoretical probability, you're dealing with a quantified measure of outcome. Okay, so what's the likelihood? So they would say likelihood or outcome. So if you want to put a number to likelihood or outcome, you're dealing with a case of probability. So what's the probability that it will rain tomorrow? What's the measured outcome? What's the chance? Okay, so that's it. So if you the general formula for probability, it's equal to, you're dealing with you have to have the count for the desired outcome. Okay, so you can say desired outcome count. So for example, if you're dealing with a deck of cards, the desired outcome, let's say for an ace of spades, would be just one. Okay, so it would be the desired outcome count for the events. How many can you actually do in just one draw? Those are the desired outcome. That's the desired outcome count, and then over total possible counts. Okay, so you're dealing with now the whole probability. We could say probability space. So for example, for a deck of cards, the probability space is actually just 52 of those cards. Okay, so that's our general definition for probability. I know that it's not very relatable, so we just try to explain to you as we go. Okay, so for example, in the first part, you're told that a fair die is thrown once. Okay, so you're dealing with only one event. So the event is what? The event is you throwing a die or somebody else throwing a die. That's an event. We say we call it an event in probability. Okay, so you're asked to find the probability of obtaining a 1. So you can actually, just in general, while we define probability, in terms of symbols, we say P, then we put brackets here. Then whatever outcome we want, we can put in here. Okay, so this one would be probability of getting a 1. It'd be equal to desired outcome count. So how many for a die, how many ones do you have? For a die, each face has its own unique number, and then we have numbers 1 through 6. Okay, so you actually have only 1. Okay, then the probability space, or the total possible counts for the die, it's actually 6. So you'll be having 1 over 6. That's it. Okay, so not too complicated. And the B part, you're asked for an odd number. So the way that I always advise people right now is you should know at least the possible outcomes, the total possible outcomes. There are 6, but then you should know all of them. So for a die, it'd be 1, 2, 3, 4, 5, and 6. Sometimes you depending on how large your sample is, sometimes you won't have to, sometimes you just use it, we call them thought experiments, where you just imagine things and then you'll be able to figure out in the same way that we're going to figure out right now. So if you're looking for odd numbers, so the desired outcome count would be this 1, and then this 3, and then this 5. Why? Because they are odd numbers. Odd numbers simply means numbers that are such that, or numbers that are such that when you divide them by 2, they actually leave a remainder. Okay. So probability, you can say probability of, you can actually just write odd number here. It's still fine. Okay, so it's still fine to write odd number. This handwriting is bad. It's equal to the total number of desired outcomes. We desire an odd number, so it'd be 3 divided by the total possible, which would be 6. But then don't leave this like the way it is right now. You're supposed to leave it in its lowest ratio. Okay, so here would be 1 over 2. Okay, so this would be it. And then for the C part, number less than 3. So again, you're dealing with your probability space. You want numbers which are less than 3. So it'd be 1 and this one. Okay, so this time your desired outcome. So you can say probability less than 3 like this. This is how I would write it. You can actually write less than 3, it's still fine, but then just to make it more mathematical, you can actually just use this less than sign. Okay, and then you move over. So you'd be getting how many numbers are less than 3? You actually just have 2 numbers. And then how many do you have in the probability space? It's just 6. So here again we put in its lowest form, so it'd be 1 over 3, so 1/3. Okay, and then the D part, now we're dealing with which numbers are prime numbers. So prime numbers, we should know the definition. A prime number is a number that has exactly 2 factors. Okay, so prime number, so any number that has exactly 2 factors, we actually call that number a prime number. Okay, so a prime number is any number that has exactly 2 factors. So in our case, the prime numbers would be what? It would be having this 2 here, it's a prime number, and this 3 here, it's a prime number, and this 5 here, it's a prime number. I'll explain shortly why they are prime numbers. So 2, the factors there, 2 and 1. 3, the factors there, 3 and 1. 5, the factors there, 5 and 1. Okay, so you can see that each and every number that I've included here actually has 2 factors. For 1, it just has 1. So this is a problem. It doesn't have 2 factors. So that's why we didn't include 1. So you actually have these 3 there. So probability, you can say probability of prime. It's still fine. Whatever you write in brackets there. Okay, it's equal to 3 over the total count. It's 6, which is equal to half. Okay, so that's it. You'll be done with this one. Let's quickly move to the next one if we have the time. We still have the time, so it's good enough. So here, one letter is selected from the word mathematics. Find the probability of selecting an A. So again, you're finding the probability of selecting an A. You're dealing with probability where you have to count the number of outcomes. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the number of total possible outcomes for this letter, picking up for this word, picking up any letter there, it's actually 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so probability of picking an A, how many A's do you have? We just have 2, so this one will be 2 over 11. Okay, so this one it's A, and then B, picking an M would be 2 over 11 again, since we have 2 M's, so you have this M and this M. Okay, so it's actually 2 over 11. The probability space, it's not really changing, but then this is not always the case. Okay, so hopefully we'll be able to get more complicated examples where you can show that, and then A, M, or T. Okay, so this is a very good buzzword. Whenever you see or, you're dealing with independent events, so you're supposed to add. So, or just whenever you see or in probability, just know that it's addition of what? Of probabilities. And I'll be able to show you this a little better in later examples. But then whenever you see AND, it means multiplication of probabilities. Just bear that in mind, okay? So just know that you're dealing with independent events, and you're dealing with addition of probabilities. So probability, you can say probability of M, it will be M union T, okay? So N, M, O, or T. So you're uniting those probabilities. It's equal to probability of M plus probability of T, okay? So whenever you see O, just know that we're dealing with our independent events, and we have to use the addition rule. So here, probability of M, we had gotten it is 2/11, and now probability of T, how many T's do we have? We actually have 2 as well, so it'll be 2/11. So why am I writing 3 here? 2/11, so 2/11 plus 2/11, you get 4/11. Okay, so this one will be 4/11. And D, you asked what's the probability of getting a vowel. So you have to know how many vowels you have there. So you have vowels, you have 1. So you can say probability of getting, you can say vowel, you can say just V. Probability of vowel, it's 1 here, 2, 3, 4. So it's just 4/11. Okay, so vowels, it's R, A, E, O, U. Okay, so that's stuff we used to do in primary school. So 1, 2, 3, 4. So it's just 4/11. And then E, the probability of getting a K. You can pause this video and then see whether you'll be able to find it. Here you don't have any K, so it's just 0. Okay, so that's it. So you read 0/11, which is 0. So I'll catch you in the next video. Thanks so much for watching. Make sure you subscribe. It helps us, other people, discover our channel. Okay, so thanks so much for watching. Cheers. Bye. Yuba out.